Okay. So welcome to 2.5 Measures of Central Tendency. It's going to be a short lesson today. And basically we are going to, let me just get rid of this. We are going to review stuff that we learned in the first, I think the second day of the course. We kind of learned a little bit about this. So if you have a bunch of data, how do you tell people what the data is like? You know, what number do you tell them? And one of the ways you can talk about things is how much is everything clustered towards the middle. And that's what we're going to do today. What we're going to do on Tuesday is measures of spread or dispersion, and that's a little bit more complicated. We'll finally figure out how to actually calculate the standard deviation from scratch, as opposed to just getting our calculators to do it, and find out more about what it means. So anyway, I'll just go through this very quickly. So the measures of central tendency, the values around which a set of data tends to cluster. The three most commonly measured used measures of central tendency are the mean, median, and mode. That shouldn't come as any surprise. You've been using that for a while now. And just to let you know that there's two different letters for mean. If you're talking about a population, we use the symbol mu, the Greek letter mu. And if you're talking about this mean of a sample, it's X bar. But the formula is the exact same thing. So you have two different symbols. And we'll go through this about how to do ungrouped data and how to do grouped data. And we'll talk about that in a while. So I'll explain all that. All right. And we'll talk about the median, which you already know is the middle number. The mode is the most common value. Outliers. Here's a general definition. On Tuesday, we'll talk more about outliers and actually come up with a formula for you guys to use to determine if a value is an outlier or not. Now, for today and up until now, you just kind of off the top of your head say, well, this number is a little far from the rest, but that's not. There is a mathematical definition for what an outlier is, and we'll use that on Tuesday. We'll talk about how to calculate if a value is an outlier or not. We'll talk about the weighted mean. The weighted mean is something like how we calculate your marks. We have weights for knowledge, communication, thinking, application. How do you calculate the weighted mean? And you guys already know this. A little bit of homework. It's up to you whether you want to do that or not, but it's pretty straightforward today. All right. So this was the notes, and hopefully you've printed this out. Okay, so yeah, we're here to talk about these three. Anyway, you can read that on your own, and you probably already know it anyway. All right. Next page. Which measure should I use? There's no set rule governing which measure or center of tendency you should use to describe a set of data. However, the following are some guidelines. Let's look at if there's outliers. An outlier, a value in a data set that is very different from all the others, will affect the mean the most. If data contains outliers, use the median. If you see that there's one big outlier or a bunch of outliers, it's better to quote the median as opposed to the mean. It's more, it gives a more accurate representation. For example, let's say you have the values 2, 4, 7, 9, 56. Is there an outlier there? Is there an outlier there? Yeah, 56. Yeah, 56 is quite a bit far from all the other values. So if you calculate the mean, it's pretty easy to do. You add them all up, divide by 5. You'll get, I think it's 15.6. Somebody want to calculate that for me, but you can trust me on it. I think it's 15.6. What is the mean?
Got that too.
What's that?
Yeah, we got that too.
Oh, wow. Okay, you guys are fast. What's the median? That's easy to, if you only have 5 digits, 5 values, it's pretty easy to calculate. The median is? 7. Okay, let's do the same thing for the second one. What's the mean? What's the median?
6.8.
6.8. So, and the median is also 7. So when you have an outlier, it affected the mean a lot. And when you don't have an outlier, the mean and the median are pretty close together, right? So here, 56 is an outlier. Notice how much it affects the mean, whereas the median is unaffected. So, if data is roughly so if you have an outlier, you use the median is better. Okay. We're going to use the median. 2. If the data is roughly symmetric, the blank and the blank will be close. What words should be there? Mean and actually the mode too. So we don't really care about the mode too much. So we'll just do the mean and the median will be close. We already learned about that with the normal distribution. This kind of looks like a normal distribution, and so you can use either one. Doesn't really matter. However, if the data is strongly skewed, either positive skewed or negatively skewed, which one is this? Positive or negative?
Positive.
Positive. If the tail's on the positive side, it's positive. The mean has been pulled in the positive direction. So you can see here the mean is being pulled that way more so than the median. So, so if the data is strongly skewed, the median may best represent the central tendency of the data set. So it's really up to you, but sometimes you use the mean, sometimes you use the median, but better to use the median if it's skewed or if there's outliers. 4. If the data is non-numeric, i.e. color, or the frequency of the data is more important than the value, let's say a shoe size, then the blank should be used. What do you think?
The mode.
The mode. Okay. Yeah, if anything non-numerical data scale on the x-axis, you would use the mode. You just tell your audience what is the most common value, common thing. Okay. All right. Let's do some very simple calculations. The data management class has just wrote a quiz. Here are a sample of the marks. Determine the mean, median, and mode. And so that's pretty easy to do. Here's for the mean. Are we going to use mu or x bar? Technically, the data.
X bar.
Well, is this the whole class or is this a sample of the class? Oh, it's sample. It's a sample. Okay, so technically we should use x bar then if it says sample. If you don't know, it doesn't really matter. It matters more when you do the measures of spread that we do on Tuesday, that there's a slightly different formula if it's a sample or a population. But for mean, it doesn't make any difference. It's the same formula. But for dispersion, for spread, it makes a little bit of difference. So here the only thing is just what do we call it? Do we call it mu or x bar? If it's sample, it's x bar. Okay. So all it is, it's the sum of all the values, all the x values, divided by n, which is or actually it should be little n, right? Little n is the number in the sample. Big N, sorry for messing that up. Let's go. I think I briefly talked about n is, if you have a sample, n is the number of things in your sample. Big N is the number of the total things in the population. So even that symbol is different. One is capital N, one small N, but don't get too caught. It doesn't really matter that much. So technically it's a small n, not a big N. So if we add them all up, you want to take my word for it? Just take my word for it. It's 1,000.
70.4.
What'd you get?
For the mean, I got 70.4.
All right, that's you got it right. So there's 15 values. If you add them all up, it's 1,056. It's 70.4%. Is because these are all percentages. All right, the median. Again, you could have done this in grade. You probably did this in what, grade 6 or something. So this is pretty easy stuff. So if you wanted to, what's the easiest way to calculate the median?
The middle number?
The middle number. And that's kind of weird when it's, if you write them, I wrote them in numerical order, and I got this 58, what's the next one? Oh, sorry, 53, 58, 61, 65, 65, 72, 77, 84, 87. What the heck is that one? 88, 91, 95, 97. Okay, in numerical order. So which one's the median? We have 15 values. It's going to be number. Choose what's the middle number out of 15? Which one do you choose? Number 7 or number 8? Middle is 7.
Between both of them. Wait, no. Number 8?
Yeah, it's number 8. So if you 1, 2, 3, 4, 5, 6, 7, 8, it's got to be this one. Here we have 7 before it, and then 7 after it. So the 8th value is the middle of 15. Does that make sense?
Yeah.
Okay. The 8th, choose value number 8. And if it was an even number, what would you do? If you have an even number of values, what would you do?
You take between the two middle numbers?
Yeah. Let's say I had 100 here. I'd have 16 values, and then I would take the average of the middle two. It would be 72 plus 77 divided by 2. So it would be the middle of those two. All right. But so choose value number 8, which equals 72%. And what's the mode?
65.
65. There's 2 of them. There's only one with 2. All right. And what's the best measure of central tendency? What would be the best one? Which one? If somebody asks you, give me a number that represents this data, what number would you give them? The mean, the median, or the mode?
Median.
The median, yeah. The median would probably be the best one. Why?
Because it's in the middle?
No.
Because it's not affected by any outlier.
Yeah. There's an outlier. This is an outlier. And the rule is if you have an outlier, the best number to report back would be the median if you have an outlier. So median is the best. Sorry, median is best. Why? Because data contains an outlier, which is the outlier. The outlier is 15%. Okay. Pretty easy stuff. 2. Let's calculate how to determine a weighted mean. On this last test, I'll put you into the notes here, Jazz. Jazz Grant earned 17 out of 20 in knowledge, 23 out of 25 in application, 90 out of 100 in communication, and 6.5 out of 10 in thinking. If this was your only mark in the whole course, Jazz,
pretty accurate.
What would be your final mark? If this is your only assessment in the whole course, but the things are weighted: 30% for knowledge, 40% for application, and 15 for the rest. 15 for thinking and 15 for
I've spent the last 4 years never learning how to adjust for weighting. I'll be honest, sir. I never learned it, and I just go with whatever teacher says.
Okay.
You know?
Well, it's a good thing we did this after 4 years. It doesn't say weighting here. I don't have the weighting formula. I thought I had the weighting formula here. No, I do not. Okay. Well, I'm going to give you the formula. So let's say we can use X bar or mu. Let's use X bar. X bar, and we're going to put W for weighted. So this is the weighted mean. If it's of sample or mu with a W for mean of a population. But all right. So it's going to equal the sum of the weights. Wi is the you're going to have different weights, and the weights here are 30%, 40%, and 15%. So that's what that is. So you have different weights, and you have different values, right? Divided by the sum of all the weights. Okay. Did I write that down right? I think there's a. Yeah. That's what it should be. Sorry, there should be a sum figure at the top and a sum figure on the bottom. All right, so let's figure this out. So let's do. You have 4 marks and we have 4 weights. All you have to do is just sum up each mark by each weight. So let's do the first one. 17 out of 20 in knowledge. So let's just write the mark. That's the X. X is your mark. So 17 out of 20. All right, and then we're going to multiply it by the weight. It's weighted 40%. So sorry, 30%. So let's put that as a decimal. Okay, so multiply the weight times the mark. Okay, but you have to sum up all of them. So that's just the first one. So let's do the second one. We have 40% in application. What was your application mark, Jazz? 23 out of 25.
9 out of, well, sorry, wrong one. 22 out of 25.
23 out of 25, you got an application. All right.
And it's worth 40.
And it's worth 40%, so I'm putting a 0.4. And then we have 90 out of 100 in communication, so 90 out of 100. And it's worth 15%.
Yeah.
And then it's going to be
15%.
0.15 again. And then the last one's going to be, what the heck was your mark? 6.5.
6.5.
Oh, you blew the thinking question.
It's no surprise there.
Okay, so that's that. It's a sum. That's why that's the symbol for sum. Sum of what? All the weights times all the marks over the sum of all the weights. Now, typically, these will add up to 100%. Or if you do it as these guys, it'll add up to 1. But doesn't have to add up to 1. Like the way we do it as a percentage, it adds up to 1. What was this? This was 6.5 out of 10, right? Okay. Right, so the sum of all the weights is 0.3, 30%, plus 0.4, 40%, plus 0.15, plus 0.15. Oh, actually, no. That adds up to 100. Yeah, but they don't have to. They don't have to add up to a nice number. So that adds up to 1. Adds up to 1 or 100%. So let's finish this. If you want to calculate that, does anybody want to give me a number? 0.3 times 17 out of 20?
I did it like fully.
Okay.
I got 0.8555.
Yeah, the answer is 0.8555, or so basically you got an 86% on this test. Hide this. You got an 86%, but if you do the step above, you would get a mark of 0.255. That's the contribution of your knowledge, plus the contribution of your application would be, if you times it by the weighting, would be that. The contribution of your communication, 135, and the contribution of your thinking. Okay, those are the 4 contributions, and then these things just add up to 1. Again, in this particular case, they add up to 1, but the weightings don't have to add up to 1. Sometimes they won't. All right, so that's how you do it. So, seriously, that's the first time you figured out how to do a weighted average?
Yeah, Gaddy tried once, and then I said no. And then I was like, he was trying to explain to me what my mark was, and then my brain, I just turned it off, and I'm just like, it's okay, I'll just check teaches this whenever you post it.
Okay,
and then
well, it's going to be, so this is, you can calculate your mark on the first test, but once you have a second test, it makes it more complicated. Now you have to, average other tests in it. But if you only had 1 mark, it would be easy to find out what you had on the test, what your marking teacher says would be. Okay, that's weighted mean. So the sum of all the weights times all the values divided by the sum of all the weights. All right, let's do page 2, and then we're going to be done. Where's the other page to this thing? Excuse me. Is that it? Yeah. Wow, that's it. Okay. So let's determine the mean and median for grouped data. So this is a very small data set. There's only 3 groupings. Students in an English class were asked how many hours a day they spend on the computer. The table below summarizes their responses. So you have group data. People that are in the 0 to 2 hours, there's 5 of them. 2 to 4 hours on the computer, 10 students. 4 to 6 hours on the computer, 3 students. That's a lot of time on a computer, but I guess maybe in a pandemic that's true. You guys probably spend a lot of time on a computer now. All right, so we're going to determine the mean and median for group data. How do we do that? So that's the process that we're going to do. So let's just copy down the hours. And I'm assuming that, let's say you were exactly 2 hours. Where would you put it in? If you typically go like this, if you were exactly 2 hours, where would you be in? Category 1 or Category 2? Typically, the way most people do it.
The first one?
Okay. Well, actually, most people do it the other way around. They put you in the higher group. So if you have 2 hours, you're right on the border, and it's kind of written like this. Generally speaking, people would put you in the higher one. So even though it's not written, we can actually do something like, I don't know. Remember how we talked about this before?
Yeah.
So this means up to 2 hours, not including 2 hours. This thing says including the 2 hours. So that way you can make it more clear. But if it's not stated with the brackets, you kind of just assume that that's the case, even though it should be more clear. So how do you calculate group data? You don't know exactly where these people are, where these 5 people are, but you're going to just assume that they're all at the midpoint. Okay, because they could be at 0, they could be at 2, but the only way you can, because you don't have the original data, you just have the grouping. So we're just going to assume that all 5 people are at the midpoint, and the midpoint between 0 and 2 is, don't think too hard. What's halfway between 0 and 2? 1, okay. And the midpoint between 2 and 4 is 3. The midpoint between 4 and 6 is 5. The number of students, again, just copy that down. The sum of all the sum of all the frequencies. These are frequencies. This is frequency. That's why it's an F. Sum of all the frequencies is 5, 10, and 3 is 18. There's 18 students. To determine the median and the mean for group data, we have to calculate this. The frequency of each grouping times the midpoint of each grouping. Okay, so this is the midpoint. That stands for the midpoint, and this stands for the frequency. All we do is just multiplying this together. So this times this is just 5. Let's say we have 10 people, and the midpoint is at 3. So that represents this. These two multiplied together become 30. If we have 3 people and their average is 5, we don't know for sure, but we're assuming that they average out to 5 hours. So that would be a contribution of 15. So I'm just going to write the sum of all the frequencies times the values. That's what this is. I'm just summing that up, right? Oh, sorry, I should say M, not midpoints. Is 5 and 30 is 35, and 15 is 50. All right. So there's a formula for the mean, and I gave you that formula on page 1 for group data. It's this. Okay. So the formula. Let's just write that down. So let's assume this is a sample. So the formula is going to be the sum of all the frequencies times their midpoints all over the sum of just the frequencies. Okay. So it's a little bit more complicated to group data, but it's not. You know, we talk about midpoints. The only reason we're using midpoints is because we've lost the original data, all the individual entries, so we're just using the midpoints instead. All right. So all that is just this divided by that, right? Just 18 divided by 50, or let's just actually write. Where did these things come from? This number was 1 times 5. This number, we're adding another number, 3 times 10. And then we're adding 5 times 3. Okay, and that's how we got to 18. And on the bottom, we just added these guys together, numbers, the frequencies. So that would just be 5 plus 10 plus 3. That equals 18. Oh, sorry, I messed something up. This is 50. This is 50. So the average if you got this data, and somebody asks you what's the mean, what's the average number of hours students spend on the computer, you would use this formula, and you would end up with how many hours per day?
2.7.
Yeah, 777, something like that.
Yeah.
Okay, so that's how you calculate the mean of a group data. You have to use this formula. You have to use the midpoints because we've lost all the original data. We don't know exactly where in that grouping they were. The median. How do you calculate the median? Any ideas? What's the definition of median?
The middle number?
Okay. The middle value. How many kids are there?
18.
18. So so it's an even number. So if it's an even number, you have to take the average of the middle two. Which are the middle two? Is it the 8th and 9th, or the 9th and 10th? You think it's an easy question, but what is it? You have 18 values, right? It's pretty easy. You have one group of 9, and then another group of 9, right? So the first group of 9 ends on the 9th value, right? And the second group of 9 starts at the 10th value. Does that make sense?
So it's 9 and 10?
It's 9 and 10. So the median is the mean, remember, or the average of the 9th and 10th values. So where do the values 9 and 10 come in? The first 5 are here, the next 10 are here, so, and then the last 3 are here. So the 9th and 10th values are in which grouping? This one, or this one? It's got to be here, right? First 5 are here. This is from value number 6 to number 15. Yeah, and this is from 16 to 18, right? So numbers 9 and 10 fall in this group. So both of these values occur within the interval of 2 to 4 hours. Therefore, it's therefore with an E. I never know. There.
Yeah.
Therefore,
Yes, sir.
an approximate median is, I want one number. I don't want a range. So what number do I use? It's in this range. It's in this. We're definitely in here. So we don't use 2 to 4. We want one number. We use this number. We use the midpoint. Yeah. The approximate median is 3 hours. All right. Why are these values simply approximations? Does anybody want to give me a sentence answer? Okay, you guys are shy. Because we don't know where the data lie within each interval. And we are done, my friends. That's it.
Wow.
That was an easy one. Let me stop this.
Pretty fast.
Stop. There. But still 31 minutes. How could it be 31 minutes? I don't understand. I thought it was going to be 15. How is that possible?